Computer-aided manufacturing software, or CAM, not only helps translate concepts into reality, but it's also having a measurable environmental impact. With advanced tool path optimization and smart material utilization strategies, CAM programming can help reduce waste and boost precision, which means less scrap, fewer errors, and a more efficient use of resources. CAM software also can cut down on coolant usage and reduce energy consumption. Joining us today to talk about the environmental and precision benefits of computer-aided manufacturing is Jesse Trinque, an engineer at mastercam. Thank you for joining us today, Jesse.
Happy to be here.
Because our audience is so familiar with computer-aided design or CAD, why don't we first talk about how CAM integrates with various CAD software? What are the
Yeah,
benefits of the integration? How does it streamline the design to manufacturing integration?
yeah. And if we're looking at this from a engineering perspective, right, it's all benefit, right? Because I go in there and I design this component that I want to create. And if I need to make modifications down the line, somebody will say somebody else is programming it, right? And I've got this model, they're working on it, they get it programmed, and like with anything, it's an iteration process. The design is never done. So you start to make changes to it. That integration with the CAM software allows that a faster turnaround, revision, that sort of thing. There is a purposeful disconnect between CAD and CAM as well. When we talk about like an engine on an aircraft, right? The person who is designing, the engineer that is designing that engine has no business programming or the expertise to program the blade that's in that engine, right? Nor do they understand the CAD intricacies that may have to occur to get the part as they designed it off of a CNC machine. So in that case, that designer, if I'm the guy designing the aircraft engine, I do not want a machinist making modification, or a programmer making modifications to my blade that has a very specific set in that CAD model, right? Just to get it manufactured to spec. So there is a competing principle there. In the integration is good, and it is really good for a engineer, programmer, machinist, right? Somebody who's taking all three of those roles. We talk about like a startup or somebody who's got a great idea that now takes on all of these roles and produces a product. Very, very powerful to have them connected. At the same time, I don't want to say we don't want to be integrated between CAD and CAM, right? We want that integration, and it may be being able to talk with these various softwares, right? Having a fully capable and integrated model come into this CAM package that I'm using to program and make that process of going back and forth very simple. You talk about like an automotive or aerospace, the plane may be designed in CATIA, but then it's getting simulated doing FEA analysis in another software, right? Then it's going down to a shop to make all the fixturing and tooling to produce that panel or component that's on that part. And that could be designed in SolidWorks, in a second tier shop. And then that could further come down to a third tier shop that is maybe a smaller job shop that's now using, mastercam to create this one part, but they're bringing in the main model of the part from CATIA, and they need to bring in those fixtures and tooling that were designed in SolidWorks, and now put that all together in assembly and maybe make modifications to it for manufacturing. So it's really crucial that all those pieces play together. Even though we may compete in a lot of spaces, right? We still have to work together, or these components aren't going to be produced.
All right, so there have been several advancements in CAM technology, automation, artificial intelligence, machine learning. So let's talk about those a little bit. How are these trends shaping the future of machine design and manufacturing?
Yeah. Yeah, I mean, like in almost any industry, I don't think manufacturing's alone. Those terms, automation and artificial intelligence, machine learning, right? They're all the rage, right? Everybody wants to know how that will play in their specific industry or in
Sure.
their specific product, right? And I think, as we all know, they're very far from mature. There's a lot of room to see where this is going to go. And I think it has its place, and it's already showing its place in manufacturing. Just kind of as a little anecdote from myself, I bought a little consumer grade 3D printer, right? And I'm able to basically push a couple buttons, and it produces all the code and motion that's needed for that 3D printer to produce almost anything, like instantly. Um, and after I saw, after I saw that, and that has come a long way in the last 5 to 10 years from what these consumer grade 3D printers were capable of to what they can do today. And I think we'll start to see maybe an even more accelerated timeline in the manufacturing world, like for subtractive machining, right, where we're using these complex machines and producing complex parts. I do think that there is a side to that gets lost a little bit in manufacturing, and that is the art side, right? The human art that goes into producing a part, especially when we get to very complex or um, I guess aesthetic parts where you have that very human aesthetic to a part, something that you touch, feel, and see, especially in consumer products or in automotive or any of those types of parts. It's going to be very, very difficult for machine learning or artificial intelligence to gather that human perspective and put it on a manufactured part. Um, so I see that as still staying very human. But I do see, the generic run of the mill parts, the simpler parts, where the actual process that you use when you're machining it doesn't really have a huge outcome on the finished piece, as long as it's within tolerance and it's done efficiently. Yeah, that's a great spot for, you know, artificial intelligence to get involved and make that better. And we're already seeing that happen. We have, partners in industry that are leveraging our software and using this artificial intelligence to kind of take away some of that mundane programming that would happen. But I don't think we're really touching those other parts that I talked about that are still very human. Even though they're a piece of metal, they still integrate with human life, and in touch and feel and things of that
Sure.
nature. In the near term, too, I've seen this on our development side with what we'll call like micro automations, right? Where we're taking things that you're still pushing the buttons, but we're taking those tasks that used to take 15, 20 clicks, right? And you were doing that all the time, every time. So we just spend a lot of time understanding that and automating those little tasks while still giving you full control of the outcome. And I think that'll actually be useful, as some of this stuff gets automated too.
Sure, it's almost like AI is taking over the building of macros. So
Yeah.
yeah, I don't know. That's kind of how I envision it. Um, all right, so why don't we talk about how CAM can help engineers optimize their machining processes for efficiency, including toolpath strategies, material usage, and energy consumption.
Yeah. I think a lot of that is visibility of the process before the process happens, right? So simulation is probably a huge part of that. And there's various levels of simulation too, right? There's a very like high level overview. How does this work? And that comes even, on the design side, some of the best design engineers are the ones who could theoretically or have taken a part all the way through to completion on manufacturing, right? And they've seen that process, they understand that process. Well, their designs are going to be inherently better or inherently more manufacturable. And that is that seeing that knowledge of how CAM takes that part in and produces G code to put it out on the machine and understanding it. Maybe not having intimate knowledge with how it works, but understanding where where these changes have to be made, or um, even doing a rough, quick little program to find the flaws in your design, right, and roll that back into your design. You're going to end up with a better part instead of sending this out to the shop floor to get made, or contracting it out to get made, and then coming back with all these changes. The more you can influence that up front, um, the better your design is going to be. You kind of talked about, you mentioned energy consumption, and I think, and we don't often think about this in the cam world as like actual energy consumption, right? All we talk about is like toolpath efficiency or cycle times, or and so that kind of strikes me as, well, we don't really address energy consumption, but we are. That's exactly what I mean, you reduce a cycle time, you reduced everything, right?
Yeah.
You reduce your coolant consumption, how often all this PM has to happen on a machine, um, how many watts of energy, right, went in, how many watts of electricity went into that process. And now I'm kind of thinking like something like dynamic mill, right? Our dynamic motion technology that has revolutionized the way you rough material off of a part. It'd be interesting almost to do a study and see like how many megawatts of power we save in electricity we save a year just from that one tool path, right? If you kind of took the overview of how much power these machines would be consuming, um, and kind of amortize that over the whole entire manufacturing industry, it would probably be phenomenal.
All right, so let's switch gears a little bit. So, what broader manufacturing trends is mastercam watching, and how does the company adapt its software to meet those evolving industry needs?
I guess one of the trends is connectivity and feedback loops, right? How the shop floor is becoming more connected. I know we've been talking about industry 4.0, like that next generation of machining, and it's growing and catching some traction, right? But how do we take on our side, how do we take this massive amount of information, parse it down into something useful, and create some feedback into the software or into a program to enhance that program based on that empirical data that we're collecting out on the floor.